Now we have electromagnetic spectrum. See, as I told you that we have electromagnetic waves, and you all know that the electromagnetic waves are those which can travel through medium as well as through vacuum, right? So these waves actually, there are so many electromagnetic waves, and when we try to you can say arrange them in a definite order, the electromagnetic waves, what we get is the electromagnetic spectrum. So what is electromagnetic spectrum? It is the arrangement of different electromagnetic radiations, different type of electromagnetic radiations according to decreasing order of wavelength and increasing frequency. Or you can say increasing order of wavelength and decreasing frequency, whatever, because whenever the wave possess high wavelength, then it possess the low frequency, and when it possess high frequency, it possess the low wavelength, right? So the arrangement of the different electromagnetic radiations according to a definite order, increasing or a decreasing order of wavelength and frequency, what we obtain is the electromagnetic spectrum. Here I have drawn an electromagnetic spectrum for you, indicating the electromagnetic waves, and this spectrum I have drawn in order of decreasing frequency and increasing wavelength, right? Or sorry, decreasing wavelength and increasing frequency. So here we have the radio waves. As the first I'll just recall the names: radio waves, microwaves, infrared, visible region, which includes the whole VIBGYOR, right? Violet, indigo, blue, green, yellow, orange, red. We have ultraviolet radiations, X-rays, gamma rays and cosmic rays. Now, as I told you that I have arranged these radiations according to the increasing frequencies. So, just take a look on the frequency. Radio waves is 10 raised to power 4 Hertz, 10 raised to power 10, 13. It ranges, the visible region is actually a combination of many radiations. So, it ranges from 3.95 into 10 raised to power 14 to 7.9 into 10 raised to power 14 Hertz. So, this is the range of the visible region. UV rays 10 raised to power 16, X-rays 10 raised to power 19, gamma 10 raised to power 20, cosmic, it ranges or you can say the frequency is more than 10 raised to power 20, and it may extend up to an infinity. So this is about, we are talking, as you can see, that frequency is increasing. So if we look for the wavelength, so obviously there will be a decrease in wavelength. See, visible region has wavelength, means the range is between 400 to 700 nanometer. It is measured in nanometer, and you know that 1 nanometer is equal to 10 raised to power minus 9 meters, right? So these radiations, the radio, the micro and the infrared, they possess wavelength more than 700 nanometer, right? And after visible we have UV, X-rays, gamma and cosmic rays. They possess wavelength less than 400. So they are having higher frequency but less wavelength, and they are having you can say that low frequency but high wavelength. They have high wavelength, low frequency, they have low wavelength but high frequency. And visible region we have already talked about, it is the 400 to the 700 nanometer is the range for the wavelength, and frequency is 3.95 into 7 and extend up to 7.9 into 10 raised to power 14. This is the visible region, that is the VIBGYOR, violet, blue, violet, indigo, blue, green, yellow, orange and red. So this is about the electromagnetic spectrum. Now, you are familiar with the you can say characteristics of wave also. As you know that if we want to talk about the characteristics, so we have certain parameters, wave parameters. Suppose this is my wave, right? So as you know, this elevation is called as crest and this depression is called as trough, right? So you have studied these wave parameters in the lower classes also, but just to make you more aware about it, so that you may means if, or you can say to have a thorough knowledge, I am just going to repeat it again. So we have is, what is crest? Crest is an elevation and trough is a depression, the first thing. And one electromagnetic wave consists of one crest and one trough. Second we have is you can say amplitude. What is amplitude? It is the maximum, this is the mean position. This straight line is indicating the mean position, right? So the what is the amplitude? It is maximum displacement of particle in either upward or in downward direction. This is amplitude. So what is amplitude? It is maximum displacement of particle in either direction. In either direction, maybe up, maybe down. Third we have is the wavelength. Third we have is the wavelength. As you can see, this is crust and even this is crust, this is trough and even this is trough, right? So what is a wavelength? It is the distance between two consecutive crusts. Consecutive means one, you can say the one which is just after that. So distance between two consecutive crusts or two consecutive trough. So what is wavelength? Wavelength is distance between two consecutive, it has to be consecutive, okay? Two consecutive crust or trough. It is the distance between two consecutive crust or trough. And how we denote wavelength? We denote wavelength with a symbol. This is called as lambda and it is measured in unit, that is the nanometer. Next term we have is the frequency. Next we have is the frequency. It is number of waves produced in 1 second. As you can see here, I have drawn two waves. So if I say that in 1 second I observe these number of waves, so that means here the frequency is 2 hertz. So what is frequency? Number of waves in 1 second. Like I am telling you that in 1 second I got 2 waves. So obviously how I am going to calculate the frequency? It is the number of waves produced per second and it is denoted by nu. The symbol is nu and the unit in which it is measured is hertz. So frequency is number of waves produced in 1 second. Right. Next term we have is related to the wave parameter, time period. As you know that when the particles are vibrating, they are vibrating like this, right? So we have one oscillation means one complete movement of particle. Before taking time period, I will take oscillation. What is oscillation? It is complete movement of particle about its mean position. And as we know that in electromagnetic wave, particle vibrate up and down, right? So we can say that oscillation is the complete movement of particle about its mean position. That means this is the mean position, so it is moving up and then at the same time it is coming down also. So this is called one oscillation, right? And one oscillation means one wave and one wave means one crest and one trough. You have seen that one movement in upward and one in downward. So upward is indicating crest and downward is indicating the trough. So oscillation is the complete movement of particle about its mean position. And the time the particle take to complete one oscillation is time period, right? So what is time period? Time taken by particle to complete one oscillation. Time taken by particle to complete one oscillation. Next we have is the velocity. Velocity is, as you know that it is the speed only but in a particular direction. So you can say velocity is the speed with which wave travels. It is the speed with which wave travels and it is measured in unit meter per second and bigger unit kilometer per hour as the same units which you use for velocity. So here the velocity is the same as you have done in the motion chapters. So this is all about the wave parameters. I think you got it. The wave, electromagnetic wave, you know that consists of one crest, one trough and it doesn't need any medium. It can travel through vacuum also and speed also you know. And if you talk about wave parameters, amplitude is the maximum displacement in either direction. Wavelength, distance between two consecutive crusts or may be taken as distance between two consecutive trough, but it has to be consecutive. Third we have is the wavelength. Wavelength we have discussed. Frequency, number of waves produced in 1 second measured in hertz. And time oscillation, complete movement of particle about its mean position and the time which the particle take to complete movement is called as time period. And velocity is speed with which wave travels. And you should know that time period and frequency are related to each other. How? Time period is equal to 1 over f. Time period is equal to 1 over f, and there is also one more relation, that is nu is equal to c over lambda. So what is nu? Nu is frequency, c is velocity, but here we have taken c indicating the speed of light. Otherwise it is velocity only. You may write v also instead of c. And lambda you have know is the wavelength. So this is the relation indicating between frequency, velocity and wavelength. That is nu is equal to v over lambda, but if you are talking about light, then the velocity of light is taken as c, so we may write nu is equal to c over lambda. So these are two relations you need to know, because you may get questions based on it where you will be given a time period and you need to find the frequency, or you are given with frequency, you need to find, and you are asked to find the time period. Likewise, you may get a question where you may be using this relation between the frequency, wavelength and velocity. So this is the wave parameter, right? So this is all about the electromagnetic wave theory. So we are going to discuss now that what you can say what processes, or you can say what phenomena, actually that this will be a correct word, what phenomena can be explained on the basis of electromagnetic theory, and what phenomenons are not explained on the basis of electromagnetic wave theory. Because whenever any theory comes, it should be applicable to all kind of all kind of waves actually. So we are just going to see in the next slide that does the other related phenomena, or the all phenomena which are related to light or the wave obeys this theory or not, and if not, then what is the drawback. Till that time what you do is you study about this wave theory, because you need to be familiar with this theory first. This theory, this spectrum and the wave parameters, and you should know that how to draw it, right? Then we will be starting that what things can be resolved by this theory and what things cannot be resolved by this theory, and what changes we have to make in this theory, or is there any other theory which is trying to explain those phenomena which are not explained by it, right? So just learn it first, try to write it, and please make it clear whenever you are learning something, whenever you are make a habit to write and learn, right? So this is all about the theory.